Okay, so in this video, we're going to be doing some practice problem with extrema, okay, and increasing, decreasing functions. So last video, we talked about what extrema are, what's a maximum, what's a minimum, and we talked about how to find them. So in this video, we're just going to be doing some couple of practice problems, okay? So let's say we had a function. You had a function f of x. I have my orange marker again. Let's turn to our signature black. F of x equals x squared over x squared plus 3. Okay? So you can't really graph this function, okay, just yet. You can't really graph this function. So we're going to have to rely on pure math. Okay, we want to find all the absolute extrema on the interval, the closed interval from -1 to 1. It's interval notation. Okay, so all the points including -1 and 1. Good. So what we do is find the critical points. We're going to find f prime first. F prime of x, we're going to use our old friend, or to some people enemy, the quotient rule. Okay? So the top function, the derivative of the top function times bottom minus derivative of bottom times top. All of that over the bottom squared. And we get 2x. Well, we're not going to multiply this because we have a common factor. What I'm going to do is, factor 2x out. It's much more convenient. Okay? And these two cancel. And we have 6x over x squared plus 3 squared. So now we want to find the critical points. Where does f prime equal 0 or undefined? So the undefined case we can rule out. Why? Because you're having something squared plus an integer, plus a positive integer, which means the bottom value will always be positive, and you're squaring that as well. So no wonder what you do to it. You will always have a positive integer. No real value of x will make the derivative undefined. Okay, so the undefined case is out. Let's check our defined values. Okay, where does it equal 0? So we look at the top. 6x equals 0. And you could just eyeball that equation. You could see that this is true when x equals 0. So we have a critical point at x equals 0. So what we're going to do is test f of -1, our left end point, f of 0, which is our critical point, and f of 1, which is our right end point. So f of -1 equals -1 squared, that's 1, over -1 squared is 1 plus 3. So we have 1/4. F of 0 equals 0 squared over 0 plus 3, which is obviously 0. We have f of 1. F of 1 is 1 squared over 1 plus 3. So you have f of -1, f of 1, and 0. Okay? So you know for a fact that at x equals 0, you have the absolute minimum. The absolute minimum. The absolute maximum is 1/4. That happens at both f of 1, at x equals -1, and x equals 1. So you have an absolute maximum value is 1/4. See, it's not that hard. You just take the derivative, set it equal to 0. Okay? So now we're gonna abandon the closed interval, and we're gonna look at relative maximum. We're gonna do a problem from relative max, and this one we're going to do a good one. We're gonna do a good one. So we have f of x equals x to the 1/3 power plus 1. Okay, so the cube root of x plus 1. So f prime of x, and we're asked to find the relative extrema, and so relative extrema. So first we're going to find where it's increasing or decreasing. Then we're going to find the relative extrema. Okay, so we're going to find the derivative of x to the cube root of x. Okay, so you have x to the -2/3 times 1/3. Yep, I did that right. Scared for a moment. So you have x to the -2/3 and 1/3. So if you look over here, this could be written as 1/3x to the 2/3 power. Now, we want to see where this equals either 0 or undefined. Okay? So this does not equal 0 anywhere. Okay? Because this approaches 0 as x approaches infinity. Remember from our little thing on infinite limits? Yes. As x approaches infinity, this will approach 0. So you can't really find where the derivative equals 0. However, there is a value where the derivative is undefined. The derivative is undefined at x equals 0. Okay, you plug in 0, you get an undefined answer. 1/0 to be exact. Well, not really exact. It's not a value. It's undefined. So we're going to test x equals 0. X equals 0. So we're going to test values to the left of 0 and to the right of 0. So let's test the value to the left of 0. Let's say -1 for convenience. F prime of -1. Okay, f prime of -1 is 1/3 times -1 to the 2/3 power. Well, -1 to the 2/3 power is just 1. So you have a positive answer over here. Let's try f prime of 1. So that's 1/3 times 1. So you get the exact same answer. So it's increasing over here as well. It's positive over here as well. Okay, just a minute. So it's positive and positive. Okay, just want to use green. So because the derivative does not change sign, okay, the graph kind of looks like this. Okay? There's no maximum point or minimum point. This is a dud, a neither point. And in case you're curious, the graph of f kind of looks like this. It's not really exact, but you could see that the tangent line is vertical at this point. So it's undefined. However, it's always increasing. Always increasing. Okay, so you solve two problems in one. There's no relative extrema, none, none, and it increases for all x. It's increasing for all x. Well, except at x equals 0. Okay? Because the derivative is undefined there. But to left of x and to right of x, so more accurately be 0, 0 to infinity. Okay, let's do one more. Okay, just to get the hang of this. Oh, holy smokes. Let's do another one, okay? So this one is a trig one, because everyone hates the trig functions. So you have root 3 sine of x plus cosine of x. Okay, we want to find where it's increasing or decreasing and all the relative extrema, the maximum and minimum points, relative maximum minimum points from 0 to 2 pi. And the only reason why they put this interval, is because this is a trig function, so it repeats. So this is just to, you know, not get an infinite number of extrema points. Okay, so you don't have infinite work to do. So first you have to find our derivative. Okay? So the derivative of this should be pretty good at taking derivatives now. You get root 3 cosine of x. Root 3 cos x minus sine of x. Minus sine of x. And we want to see where this equals 0 or undefined. Okay? But this can be undefined anywhere. It's differentiable. It's a trig function. So we want to see where this equals 0. That means what I'm going to do here, okay? What I'm going to do here is going to use something called the tangent function. Little trig identity here, okay? The reason why I'm doing this is that we can replace sine of x with tangent of x times the cosine of x. Now we can factor. Okay? So we're going to factor out cosine of x, cos x, times root 3 minus the tangent of x. So when we're going to find out where cosine of x equals 0, okay, cosine of x is equal to 0 at x equals 0 and x equals pi. We use radians here, okay? X equals 0 and x equals pi. So that's where f prime is equal to 0. Or we'd look at the second factor. Look at the second factor. And we want to find where tangent of x equals positive root 3. Okay, and that occurs at pi over 3, not 2 pi over 3, because that's negative. The tangent of 2 pi over 3 is negative root 3. But 4 pi over 3 works. 4 pi over 3 works. Yes, 4 pi over 3 does work. So what we're going to do now is set up our number line, okay? However, this is a deceptively simple problem. Not really simple, but we have some extra solutions that we really don't want or don't need. The solutions for cosine of x are not actually solutions. They came because we replaced another cosine of x with, when we substituted tan of x, cosine of x, we introduced some extraneous solutions, 0 and pi. You can check over here. Cosine of 0 is 1 times root 3 is root 3 minus sine of 0 is 0. So we get root 3 equals 0. So that's absurd. And the exact same thing happens at pi, except we have negative root 3 equals 0. So these are out. 0 and pi are extraneous. However, pi over 3 and 4 pi over 3 does work. Okay, cosine of pi over 3 is 1/2 minus sine of pi over 3. We get 0. This exact same thing happens at 4 pi over 3. So these are good numbers. And 4 pi over 3. There are infinitely more solutions, but we're only looking for solutions from 0 to 2 pi. Okay, so now we're going to find out where it's increasing or decreasing. So let's check 0. Okay, so we kind of did 0 when we tested for extraneous solutions, but we can do it again. Cosine of x, cosine of 0 is 1 times root 3 is root 3 minus sine of 0 is just 0. So we have root 3, which is positive. So it's increasing on this interval. Now, let's check a point from pi over 3 to 4 pi over 3. Let's try pi over 2. Okay, good convenient number. Because cosine of pi over 2 is 0. And minus sine of pi over 2, that's 1. So we have negative 1. So we get a negative value. And then if we check 3 pi over 2, we get cosine of 3 pi over 2 is 0 minus negative 1, which is positive 1. So we get plus a positive. So it's increasing. The derivative is positive from 0 to pi over 3 and 4 pi over 3 to 2 pi if we are going to go to our interval. So that's increasing. It's decreasing the interval from pi over 3 to 4 pi over 3. Okay, so now we have to find the actual extrema points. However, since this is going from positive to negative, this is our relative max. A relative max. And this will be a relative min. Relative maximum, relative minimum. Okay? And if we were to, find the actual points, we get our relative max is at point pi over 3. Then we just evaluate f of x at pi over 3. We get sine of pi over 3 is root 3 over 2. So we get 3 over 2 plus cosine of pi over 3, which is 1/2. So we get pi over 3, comma, 2. Okay, and we get 4 pi over 3 is our relative min. So sine of 4 pi over 3 is negative, so we get negative 3 over 2 plus negative 1/2. Negative 3 over 2 times, plus negative 1/2, we get negative 2. That's our solution. These are relative max and min points. And these are our intervals. Okay, and we're done.